Hey guys, it's Miss Springer. Today we're going to talk about equation applications, day 1. Grab the right packet. All right, so last week we talked about multi-step equation solving, the distributive property, combining like terms, all that good stuff. We're actually not going to do any new math this week. We're going to kind of move towards something a little bit more that has more meaning in your life. So we're taking the math that we've learned the past 6-7 weeks and we're going to apply it to real world situations. So I just want to read this really quick. This says the study of algebra helps in logical thinking and enables a person to break down a problem first and then find its solution. Although you might not see theoretical algebraic problems on a daily basis, the exposure to algebraic equations and problems at some point in life will train your mind to think logically. So to break this down in simple terms, though you might not use algebra every day in your life, I mean, I do because I'm a math teacher, and not even every day, not even when I don't do the algebra unit, but like in 5 years when you guys are away from Princeton, you guys might not be using algebra in your everyday work life. I mean, some people might be using equation solving, but this type of math, this type of problem solving kind of trains your brain to think logically, make connections, and ultimately break down a problem and find the solution. And that's what we're going to work towards today. So when am I ever going to use this? We talked about this a little bit in class prior to this lesson, but we can use equation solving in budgeting. So when to pay those monthly bills, and not when, but like how to budget things, rates, so like a paycheck, that kind of thing, making predictions. And we're going to have a couple examples today. Some math keywords, these are just to keep in mind. When you see something like altogether, increased by, total, sum, this can mean things like addition. Subtraction would be like difference, fewer, decreased by, reduce, less, something like that. Multiplication would be double, triple, times, stuff like that. Division, quotient of, shared equally, equal, how many in each, that kind of thing. So those are some math keywords for each of those operations. We're going to go ahead and start with the first problem. So this says, Miss Springer took a taxi home from the airport. The taxi fare was $2.10 per mile, and she gave the driver a tip of $5. She paid a total of $49. How far did she travel? So what do we know? I'm going to go ahead and take out our highlighter. We know that taxi fare was $2.10 per mile. She gave the driver a tip of $5, and she paid a total of $49. So what do we know? We know that they charged $2.10 per mile. We know that we gave them, so I gave them a $5 tip. So whenever you see somebody giving a tip in a word problem, that's typically going to be a constant, and that is because it's not changing, it's not being impacted by a variable. A tip is a tip, you just give it a one-time, it's a one-time thing. You're not giving them a tip every 2 minutes, that kind of thing. A tip is just $5, here you go. And then finally, she paid a total, so I'm gonna write total in quotes, and total makes us think of equals 49. So what do we need to know? We need to know how far, whoops. How far did she travel? So what do we need to know? How far did she travel? Okay, so before we can answer this last part, which is what is our answer and what does it mean, we've got to solve this equation. So I set this first one up for you. Your quiz on Thursday or Friday, depending on when you're watching this. Your quiz is going to kind of, I'm going to give you it's going to be just like the packet that you have. So it's going to be 4 equations and you're going to have to solve. I'm going to give you 2 equations and then you're going to have to solve for the other 2 equations. So I've got $2.10, so they're charging me $2.10 per mile. So $2.10 times every mile, plus that $5 tip equals the $49 that I paid. So I'm going to go ahead and highlight. I've 210, 5, and 49. I highlighted my variable term, my constant term. I'm going to go ahead and solve now. Remember, I want to move this 5 over to the left, so I'm going to go ahead and subtract, and I'm doing that because I want all my constants on the same side. I'm going to go ahead and bring down my 210m. 49 minus 5 gives me 44. And finally, I want to get that m by itself, so I'm going to do 210m divided by 210. I'm going to divide both sides by 210 just so I can go ahead and get that m by itself. So m equals 44 divided by 210, which gives us 20.95. Sorry, that's the 9. So this last question on your packet says, what is our answer and what does it mean? So I kind of want you guys to think about, typically when we see an equation like this, we're just thinking, okay, m equals 20.95, move on. But now we're doing equation solving in a context. So I want you to think about what that answer means in this problem. In the second part where it says, how far did she travel? So this part where it says, what do we need to know? That should help you figure out. So how far did she travel? That is what we were trying to solve for. We solved for it. So I'm gonna go ahead and extend my page. Miss Sprunger traveled 20.95 miles. All right. Nope. Yep, this is the next one. Just think if there's any questions you want to ask me, you can totally ask them. I'm going to go ahead and go to the next one. So this next one in your packet says 45 students went to the symphony with their parents. If you guys don't know what the symphony is, it's just like a big orchestra that puts on this really cool performance. So 45 students went to the symphony with their parents. The rest rode on 7 buses. So this is like a field trip situation. If a total of 297 students went to the symphony, how many rode on each bus? So I'm going to go ahead and get my highlighter out. I'm going to highlight the important things. So I've got 45 students. They rode on 7 buses, and there was a total of 297 students that went to the symphony. So under the first prompt where it says, what do we know? We know that there were 45 students with parents. Sorry, it's hard to write on this thing. We know that there were 7 buses. And if a total of 297, so I see the word total, total means equal, so total of 297 students. So this next part says, what do we need to know? Well, we want to know how many rode on each bus. So what do we need to know? How many students I'm trying to go down. There we go. Rode on each bus. So this is what we're trying to figure out. So I put equals 297 here, which means the expression on the left side is going to equal. No, that's not what I want. 297. So I know that there were 7 buses full of students plus 45 students that rode with their parents. So I've got 7 buses worth of students plus the 45 that went with their parents. I'm gonna go ahead and draw my line. I'm gonna highlight my variable, highlight my 2 constant terms. Remember, I want to move all of my all my constant terms over to the right so I can get my variable by itself eventually. So I'm going to go ahead and subtract 45 from both sides. And I'm doing that because the opposite of a positive term is a negative term. So I'm going to subtract 45 to move it. I'm going to bring down my 7b equals 297 minus 45. which is going to give me 252. Finally, and this makes logical sense if you think about it. Look, we've got 7B equals 252. This means on the 7 buses, we've got 252 students because we took away those 45 that rode with their parents. So this makes logical sense. So I'm going to go ahead and divide both sides by 7. B equals 36. So what is our answer and what does it mean? This means that 36 students rode on each bus. Again, if you guys have any questions, make sure you're asking me. We're going to go to number 3. Caroline has a summer job mowing lawns. She wants to earn enough money to buy a new golf cart by the end of the summer. And the one she has her eye on is $1,200. If she expects to be able to mow 50 lawns all summer and the gas for the lawnmower should cost approximately $300 for the summer, how much should she charge per yard to reach her goal? So what do we know? We want to go ahead and highlight. So we know that she has a job. She has her eye on a golf cart she wants to buy. Her goal is $1,200. She expects to be able to mow 50 lawns all summer, and her lawnmower, or the gas for her lawnmower, should cost approximately $300. So what do we know? We know that her goal is $1,200. We know that she thinks she should be able to mow 50 yards or 50 lawns. 50 yards. And she said that the gas for her lawnmower should cost approximately $300. So $300 for gas. So we need to go ahead. Also in your packet, it says, are there any math keywords? I see the word per and I see the word cost. So I'm going to write down per and I'm going to write down cost. What do we need to know? We want to know how much should she charge per yard to reach her goal. Okay. Finally, we need to come up with an equation. So when it says our goal is $1,200, that's what we're going to be setting our other expression equal to. And we're doing that because our goal is $1,200. So we want to figure out that expression that goes on the left. So some type of prediction is going to give us $1,200. So I want to make sure I have plenty of room. So okay, $1,200 equals, think about it, we're mowing 50 yards, and then we need to account for that 300 we're gonna spend on gas. So we've got 50 yards, and then that word cost is gonna be subtraction in this case. Because 50 yards minus the 300 we're going to spend on gas is going to get us to that $1,200 goal. All right. Now we've got 50y. We've got our negative 300 and our 1,200. I'm going to go ahead and take my pen, draw it down the middle. I'm going to move that 300 over. I'm going to go ahead and add 300 to both sides. That's going to cancel. I'm going to go ahead and bring down my 50y. So 50y equals 1,500. And I got that 1,500 from adding 1,200 to 300. So this means So I included that price. So that $300 that I'm gonna have to spend on gas, I included that. And now I'm gonna go ahead and divide by the number of yards. So that's the total amount of money I'll need if I still wanna meet that $1,200 goal. And then I'm gonna divide it by all the yards. I'm gonna divide 50Y by 50. I'm gonna divide 1,500 by 50. That's gonna cancel. I'm gonna be left with Y equals 1,500 divided by 50 gives me 30. So what does our answer mean? This means that Caroline should charge $30 per yard to meet her goal. All right. We don't have time for this last one. This one is about Pokemon cards. So I had people in class work on this one on your own. So go ahead and read it. Think about those important things. Go ahead and do your best on this one. All I want is an effort, a solid effort, and then you can go ahead and turn this in for credit. I just want you guys to do the number 4. Think about, are there any important keywords? Anything that I can come up with? What do we need to know? Make sure you're coming up with an equation, and then think about your answer. All right, and I will see you guys later. Let me go ahead. Make sure you ask me any questions if you have them, and I will see you all later. Bye.